Hello dear students, my name is Tatiana Vladimirovna and we continue our discussion about the electricity. Today we will have our third lecture and the name of this lecture is electric current. Last time we also talked with you about what exactly means electricity. It was our first lecture in our second module. Then we discussed with you what does it mean the nature of electricity, and let's get started our third lecture about electric currents. Exactly, electric currents is mostly confused by learners when learning electronics. A lot find it trickier when learning this concept. So we thought of clarifying this mess in your head along with teaching you some new things using creative and practical examples. Before starting, I recommend you to read our article on voltage because it is highly interconnected with the topic we are talking about today. Done reading? Then put your thinking helmets cause we're about to start learning. What is electric current? Definition: electric current can be defined as the rate of electric charge which is flowed in a certain point of a circuit. In other words, current is a measurement of how much electric charge is passed on a certain point in a given time. If you have a little bit of hard time understanding this definition, let's get to the water analogy, which we can use to explain electronics concepts pretty creatively, which we also previously used in description voltage. You might remember that we explained voltage as a pressure at the end of the pipe, which can push the water to flow along the pipe. If you turn on the tap at the end of the pipe, the water will flow out. Think of current as the amount of water flowing through the pipe. If you select a certain length or in the pipe, let's assume it's 1 meter in length. The amount of water that passes through that point in a given time is equal to the definition of current which we explained in the above description. So, in electricity, the current is the flow of electrons in a circuit. If you have more water in the tank, you will have more pressure and at the end of the pipe. So, more water amount of water will flow through the pipe. If you have less water on the tank, you will have less pressure. So, a less amount of water will flow through the pipe. Same in electricity. More voltage, then more current, and vice versa. Remember that current is a rate quantity. It means something is measured to the ratio of time, or something is over time. Velocity, displacement over time, and acceleration, velocity over time, are some examples of rate quantities. How is electric current measured? You can measure the electric current from an ammeter, or simply multimeter or galvanometer can be also used to measure the electric current. The electric current is measured from a unit called amperes, and a symbol A is used to represent it. The electric battery. Volta discovered that electricity could be created if these similar metals were connected by a conductive solution called an electrolyte. This is a simple electric cell. Also, you can study this example of positive thermal and negative thermal. The electric battery. Let's talk about this. A battery transfers chemical energy into electrical energy. Chemical reactions within the cell create a potential difference between the thermals by slowly dissolving them. This potential difference can be maintained even if a current is kept flowing until one or other thermal is completely dissolved. Electric battery Several cells connected together make a battery. Although now we refer to a single cell as a battery as well. Also, we can study one more examples of the electric battery and how it works. Electric current. Exactly, electric current has its own formula and you can see it in my screen. Unit of electric current, the ampere or A. Electric current, this is a complete circuit, is one where current can flow all the way around. Note that the schematic drawing doesn't look much like the physical circuit. Shortly about it. In order of current to flow, there must be a path from one battery terminal through the circuit and back to the other battery terminal. Only one of these circuits will work. By convention, current is defined as flowing from positive to negative. Electrons actually flow in the opposite direction, but not all currents consist of electrons. Ohm's law, resistance and resistors. Experimentally, it is found that the current in a wire is proportional to the potential difference between its ends. The ratio of voltage is current is called the resistance. In many conductors, the resistance is independent of the voltage, and this relationship is called Ohm's law. Materials that do not follow Ohm's law are called non-mec. Guys, that's all about our today's new lecture, and I hope that you will have now a little bit more information about this our new topic about electric current. After this lecture, please read the text that I have been attached in your second module. Please do reading part, speaking part, answer some questions, and if you can't do something, please connect me. See you soon. Goodbye.